Hello, this is Dr. Cole Woolley, and this lesson is called Optical Rotation and GCMS. I'm going to take the optical rotation for Oman frankincense and compare it with the optical rotation of Somalia frankincense in combination with GCMS data. Oh, this is going to be exciting. I'm using two analytical tools together to see if there's a difference in these two frankincense. So let's start out with the regional differences in the Oman frankincense. As I said before, the Hasek frankincense is the most desired, and 50 miles away there's the Mughsal frankincense. We showed that they were significantly different in terms of GCMS alpha pinene levels, and now we want to see if they're significantly different in terms of optical rotation. So when we did the study, we found that the optical rotation for Mughsal, which had high alpha pinene, was plus 30 degrees. And the optical rotation for Hasek was lower, plus 19 degrees. But remember that the alpha pinene levels were different. Is there something about the alpha pinene and the optical rotation that match? For instance, Mughsal has high alpha pinene and high optical rotation. The Hasek frankincense from Oman has a lower alpha pinene and a lower optical rotation. Well, I believe this proved that they are different chemotypes. They're related to each other very closely, like brothers, but they are significantly different. Now let's talk about the difference between the Oman frankincense and the Somalia frankincense. They are separated by a sea. They've been separated for a long period of time. Are they significantly different? Well, let's look at the optical rotation. The Oman frankincense, if you put the Hasek and Mughsal together in the data, there's a plus 30-degree optical rotation, whereas the Somalia frankincense is negative 13 degrees. This is huge. The difference in optical rotation is very significant. This is the proof I was looking for to be able to differentiate Oman frankincense from Somalia frankincense. They are definitely different species, but I need more data to be able to conclude that they are indeed distinct species. Well, remember back to the chirality or handedness of molecules. There's not just one molecule of alpha pinene, which is the major component in frankincense essential oils from Oman and Somalia. There are actually two molecules of alpha pinene. They are mirror images of each other. They are called enantiomers, and it's the abundance of one versus the other that's going to prove the difference in Somalia and Oman frankincense. When I put data together for Oman and Somalia frankincense, and I compared the data of optical rotation on the x-axis and the percent alpha pinene from the GCMS results, then it gave me this scatter plot that put Boswellia carteri from Somalia in one section in magenta, and the blue dots representing Oman frankincense, Boswellia sacra. Well, they are definitely in different regions of this, and so there must be some difference. Well, I also noticed that the carteri tended to have a line run through it this direction and sacra in this direction. So I looked at the statistical best fit for the data. This is what it looks like for the carteri frankincense from Somalia. And this is what it looks like for the Boswellia sacra frankincense from Oman. Can you see that they are completely different from each other? The carteri, as you increase the amount of alpha pinene, the optical rotation gets more negative. As you increase the alpha pinene in the Oman frankincense, the optical rotation becomes more positive. They diverge from each other. That's called enantiomeric divergence. This proved, almost without a shadow of a doubt, that Oman frankincense and Somalia frankincense are different species. They're not chemotypes. They are totally different from each other. But I needed to find more difference between the two, more information. I needed to know what the abundance was of the plus and minus alpha-pinene enantiomers in each of the frankincense essential oils. Was one more positive and one was more negative? That's what I needed to find out. So it would take some more analytical tests to be able to prove that. So that's what I was looking for. Alpha-pinene was the key. Remember, this separation of these two frankincense fields in Oman and Yemen versus Somalia is a very old separation. They're separated by the ocean. How have they differed over time? What kind of differentiation has happened because they're separated by so much water? Well, in this lesson, we've learned that if we take two analytical instruments and the data that comes from them, optical rotation and GCMS, we can show a difference between the Oman frankincense and Somali frankincense. They seem to be different because they have an enantiomeric divergence. So we need one more set of data to be able to confirm that Oman frankincense and Somalia frankincense are different. And that's why the analytical chemist needs different instrumentation in the lab to be able to prove the quality of essential oils and the differences between essential oils.